Okay, before we begin this lesson, you might want to take a look at some previous YouTube videos to help you out. We go over special right triangles, sine, cosine, and tangent, how to use the unit circle. And all that stuff is covered again in Unit 5. So if you need to review it, I highly recommend that you do. Okay, so we're going to do trig ratios on the unit circle. This is going to be a little bit different. We're not going to be using angles such as 45, 60, 30, any of those guys. These are going to be done two different ways. Okay. So the question starts like this. Given that sine of theta is, let's just say, 12 over 13, and theta is in between pi over 2 and pi, find the other 5 trig ratios. Okay, so now I might just ask you for like find cosine or just find tangent, but we're going to do all 5 just to kind of get into the others of them. Okay, so there's 2 ways to do this. You can do it by identity, which we will do second, or you can do it by picture. Okay, I prefer picture, so I'm going to need a ruler. Okay, I'm just kind of talk you through this. Okay, so this is your coordinate plane. We're going to measure angles on it. So we're going to start in standard position. Our initial position is always the positive x-axis. Initial angle is always 0. If we go counterclockwise, we get that. Now I'm told that theta lives between pi over 2 and pi, which means that the terminal side of my angle lives in the second quadrant. So again, I need my ruler. Now I don't know what this angle is, but I do know that it lands up in the second quadrant. Okay? So my angle starts here, goes here. Now what I'm going to do is I'm going to draw a reference triangle. Just like that. Notice my triangle, okay, makes a 90-degree angle with the x-axis. You never make it with the y, always the x, okay? And this guy right here is your reference angle for that triangle. Okay, so what do you know about sine? Well, sine is opposite over hypotenuse. So if I go opposite my theta, that's going to be 12. I know it doesn't look like 12, but remember, this is just for reference. And your hypotenuse is 13. Now, so first thing I notice about this triangle is it's missing a leg. So using my old buddy Pythagoras, I can find that my missing leg is 5. Now, since I'm on the left side of the x-axis, I'm on the negative side, so it's actually -5. Okay, so now I can find the other 5 trig ratios fairly quickly, at least the cosine and the tangent. So if I remember, sine of theta is 12 over 13. Cosine theta, which is adjacent over hypotenuse, that would be -5 over 13. And then tangent of theta, which is opposite over adjacent, 12 over -5. Okay? Now, in this section, they also introduce the reciprocal functions. Okay, and the reciprocal functions are the reciprocals of sine, cosine, and tangent. Okay, so 1 over sine we call cosecant. Okay, and for abbreviation's sake, it's CSC. Okay, and you basically just flip your sign over. Okay, 1 over cosine theta, that's called secant, and just flip your cosine over. Okay, 1 over tangent is called cotangent, and just flip it over. Okay, so 1 over sine would be hypotenuse over opposite. This guy, secant, would be hypotenuse over adjacent. This would be adjacent over opposite. Okay, so let's try another one using the picture, and then we'll go into doing it via identity. Okay, let's move this up. Okay, so given, let's do tangent theta is equal to, let's do negative 5 over, let's do 10. Okay, and let's say theta lives in the 4th quadrant. So that would be quadrant 4. Okay, so let's go ahead and draw it. Okay, you will find that I am big into pictures for this particular chapter. Because I find it easier. So if I'm in the 4th quadrant, oops. Okay, my angle starts here, goes all the way around, lands in the 4th quadrant, that's theta. I'm going to draw my triangle. Okay, there's my theta reference. Okay, so tangent I know is opposite over the adjacent side. So the 5 would be here, the 10 would be here. Now notice that the 10 is on the positive side of the x-axis, and that the 5 is in the negative of the y. So the negative is going to go on the 5. Okay, so now I need a hypotenuse because I don't have one. Okay, and again, we're finding all 5 or all 6 of the remaining trig ratios. So I'm going to go ahead and find my hypotenuse. Now the hypotenuse is never negative, if that helps you out at all. But it can have radicals. Okay, so now, since I have my hypotenuse, I can now find all of my trig ratios just by looking at my picture. Okay, so I can go, oh, well, sine of theta, that's opposite over hypotenuse. Okay, cosine of theta, that would be adjacent over hypotenuse. Okay, and then tangent of theta, I'm already given. Okay, now let's talk about simplifying. Okay, so I find that it's easier to find the reciprocal functions first and then simplify. So I'm going to move my ruler out of my way. Let's go ahead and find those reciprocals, and then we can worry about simplifying. Okay, because you know that Edgenuity will provide you or ask you for the most simplified answer. So usually I don't simplify until I am ready to. Okay, so let's simplify the 6 of these. Okay, so the problem here is that I've got square roots on the bottom and I've got common factors all over the place. So this guy, if I don't rationalize, would be -1 over the square root of 5. But if I do rationalize, it would be negative square root 5 over 5. This one would be 2 square root 5. But if I do rationalize, it would be 2 square root 5 over 5. This one's not so bad, -1/2. Okay, now these guys, since I flipped everything over first, is actually easier to simplify because I don't have to rationalize. Okay, so the 5's cancel. I have negative radical 5. Then negative radical 5 over 2. And then -2. Okay, and then that's how I would do it. Okay, but there's another way. So we're going to take the exact same problems. So sine is 12 over 13, and tangent is -5 over 10. Okay, and then this one we're in quad 2, and this one we're in quad 4. Okay, so we have something called a Pythagorean identity. I'll just write these on the side. Okay, so the first one is sine squared theta plus cosine squared theta is equal to 1. Then the next one is 1 plus cotangent squared theta equals cosecant squared theta. The next one is tangent squared theta plus 1 equals secant squared theta. Okay, all right. So what you can do is you can use these as well as the reciprocal identities, and there's also some identities for tangent and cotangent that are helpful. So tangent of theta is sine over cosine, and cotangent is cosine over sine. Okay? All right, so let's do the first one. Let's find cosine using a Pythagorean identity. So we're going to use this one. So we're going to find cosine. Okay, so starting with our identity, and then we're going to substitute. And do a little arithmetic. Now, if you're not so confident with fractions, this is going to get really scary really fast. But if you're okay with fractions, then it shouldn't bother you too much. Okay, now this is cosine squared. Okay, we want cosine, so we're going to take the square root. Now the problem with that is that when you take a square root, you generate a positive and a negative answer. Well, I don't want a positive and negative answer, I just want an answer. So that means I have to think about Well, do I want positive 5 over 13? Or do I want the negative 5 over 13? So I have to go back, look at what quadrant I'm in, and think about is sine, cosine, tangent positive or negative in the second quadrant. So it's cosine. I'm in the second quadrant. That would make it negative. So this is my answer. This is what we would call extraneous for this particular equation. Okay, so now since I have sine and I have cosine now, what I can do is I can use my fractional, my tangent sine over cosine to find tangent, and then I can use the reciprocals to find cosecant, secant, and cotangent. So let's do that. Okay, so there's tangent. Now, since I have the main three, I can find the reciprocals. So cosecant would be 13 over 12. Secant would be negative 13 over 5. And then cotangent would be negative 5 over 12. And that's it. Okay, so it kind of just depends on how your brain works. If your brain is kind of more picture orientated, then you like the triangle. If you like formulas and work in the algebra, then you might like this a little bit better. Okay, so let's try out the other one. So let me try to separate these two. Little sloppy there, huh? Okay, so I have tangent. Okay, so what I can do is, since I have tangent, I can use that with the secant. So let's try that. So I'm going to use tangent theta plus 1. Okay. So it's going to be 25 over 100 plus 1, like that. Now I knew to use the tangent squared plus 1 equals secant squared theta because I was started with a tangent. So you always look at what you're started with. Again, if you have fractions, you can pull a calculator or you can use the picture. Again, we're going to do square roots, so we have to figure out, well, am I going to do the positive or negative one? Okay, so let's see here. So it is in the fourth quadrant. Secant is 1 over cosine, so that's going to be positive. So you pick this one, and that one's extraneous. So now since we have tangent and secant, I can find cotangent. And I have secant. Which means I also have cosine. And then if I wanted to get super tricky, I could find sine by using tangent over cosine. And then, oops, I forgot my radical. I got cosecant. Just like that. Okay, notice I'm not simplifying these. Okay, so I'm not too sure which one would be easier for you, the picture or the formulas, but it's up to you either way. So thank you for viewing, and we're going to post another couple.